L times X of L, I sub L, 4.0375, and X of L, 125.66.
Uh, 507.3522.
507 point.
3523.
All right. We have everything we need except for the phase of
The power supply.
the power supply. So let's do it. And then we'll wrap this up, we'll take a break, we'll come back, we'll do the exact same problem again, except we will not use phasors at all.
Wait, what did we use to compute?
Pardon?
V sub L?
Sorry, what was your question?
Oh wait, did we use V sub L equals I sub L times X sub L?
Yes.
Oh, okay.
All right, so let's get rid of, any questions on this before I erase it?
You know you can do this in one iteration.
We believe in you.
I know, sorry.
Make sure I hit that 2 there.
No, we've got that square root.
You missed it.
Oh, you do it in
Dr.
the equal
Fuck.
side. And a 3.
You missed that whole arrow going down to 0.
You gotta keep going, Dr.
That
Fox.
plus
To your
sign.
right.
No!
No!
I appreciate the belief you had in me, but, reality is unpleasant.
This thing seems suboptimal.
Wait,
Could
can't you
draw a
make-
square around what you want to?
Yeah,
Does
that
it
makes,
make out?
that'd be a good idea, yeah.
Can you make the eraser bigger?
I don't know if that works.
There's some that do that.
Yeah, no, I've seen them literally
There's
do that
gotta be.
before. There's gotta be like
There
a
we go,
setting.
that.
Oh. Oh.
You can do it. One try.
Oh.
Again.
There we go.
All right, and we can paste that later.
It's gonna mess you up. You're
We
like,
should do that, okay, I wanna see that.
So.
no.
Square light mode is too much.
Yeah. It's destroying my melatonin production.
There we go. We'll make sure we leave that for the next person. All right. So we need to figure out the phase here. We need to figure out this angle. Let's actually draw here. The angle from here to here. That's the angle that we need. Well, we still have our triangle right there. And we're trying to find, well, if we know this angle here, we can just add pi over 6 to it. So let's try to find that angle. So again, law of cosines. Basically the drawing right there. This was VR. This is VL. This is epsilon sub naught. This is the angle here, which I'll label theta sub 3. And so law of cosines, VL squared equals epsilon sub naught squared plus VR squared minus 2 epsilon sub naught VR cosine of theta 3. We know VL, we know epsilon, we know everything here except for theta 3 solved.
0.9745 radians.
Anyone else get the same thing?
Still set, so. Wait a second. Why does it keep switching back to degrees?
Yeah, plenty of places where the degree radian issues that pop up.
And if whatever theta 3 is that the finalized angle, or do we have to,
Add pi over 6.
okay,
Anyone got this yet?
Almost.
Mary? What'd you get, Jake?
2.3109.
I hope it's not that because,
Uh,
oh, for the angle.
I got the same thing.
You got the same as he got?
Yeah, just mine's negative.
There's negative?
I
So we
don't know
got
what I did.
negative 2 point something and then we got 2 point something.
that's for the angle, not for the total angle?
Yeah, I don't know, that's just, I plugged in everything and then I got the arc sine of the final answer on the right side. And then I added the pi over 6 to it and I got 2.3109.
Oh, you added the pi over 6.
Yeah, I added the pi over 6. So normally before that it
Oh,
was
I did.
1.78735.
And had you added pi over 6?
No.
No.
Not with the
Okay,
answer.
No.
So you got negative 2 point something. Right?
Let me crunch it again here.
Oh wait, then what are we adding it by again? Pi over 6?
Yeah.
I got 2.3. Positive 2.3.
Alright.
Yeah.
So that was theta 3 and you got. Oh wait. Okay, that was that, and then you added the other one, so you had positive 2.3, which puts it, I think, same thing Jake had.
Perhaps. Okay.
You got something different?
Well, okay, this is really stupid, because this is just, goes back to order of operations, but
Right.
that minus VL squared, doesn't that turn into a positive, or do we just still subtract that?
Whatever VL squared is, you subtract it.
Okay, yeah, I've been doing that, okay, cool.
Yeah, the negative is not squared.
For computations like these, I always liked using Desmos.
Why Desmos?
Because if something's wrong, I just change that number.
Yep.
And then I could do like multiple calculations.
I left my calculator at home.
I redid it, and for the theta 3, I got 1.1275.
1.1275.
which I think is the same as their answer. So when I add pi over 6, nope. Oh,
Before adding pi over 6, I got 1.78.
Before adding pi over 6, I got 1.78.
Alright, so this was what you had before for theta
Yeah.
3, and then you had pi over 6, you had 2.3 something.
Yeah.
If there's another rule or integer we don't know about, I would like to know, but that's what I got twice.
And, yeah, it is this. Alright, so what is, out to several decimal places here?
2.30597.
Alright. So therefore, we've got our final phase, 2.30597.
9.
Alright, let's actually check to see if there's a mistake here. After all of that, we should be able to check the solution. Questions before I start erasing, I'll probably erase this. So my equations are the current going across the, from the power supply and for the inductor are the same. The magnitude is 4.0375 amperes times the cosine of omega t, which is, now we'll do decimal here, 314.159 radians per second times time. And then my phase shift plus 1.4787. So that is the formula for two of them. For the resistor, it's 2.3316 amperes times the cosine of that plus pi over 6. For the capacitor, 3.4347 amperes times the cosine of that plus 2 pi over 3. If we have done it correctly, the current across the inductor should be equal to the sum of these two currents. So let's just pick a point. Let's just pick a time of 0.002 seconds. At 0.002 seconds, what are my three different values here? And don't forget we're dealing with radians. And then while somebody's calculating that, our voltages, I know VR is equal to VC, which is 34974 volts. Cosine of that plus pi over 6. VPS, let's do VL, is 57.3523 volts. Cosine of that plus 3.04955. And then the power supply, or epsilon, is 300 volts. There's the cosine of that. That's 2.3. So I would like for our 8 equations here, so basically 6 calculations need to be done. For time is equal to 0.002 seconds, what are my 6 values? 6 different values.
Where those quotation marks are, those are space holders, because
For this right here.
yeah, because they're all the same.
Yeah.
Okay.
all right, give me some numbers.
So I got for the ISA power supply as -2.0627.
I got the same thing.
Okay,
Then for the ISA, the addition of them both, I got for negative, or I can give them individually.
individually,
For the ISA resistance, I got 0.94834. And then for the capacitor, I got -3.1378,
and when you add those two together,
-2.1894.
that's off by more than I would expect. Anybody else get the same numbers?
I concur with those three figures.
Okay. All right, what about down here?
One second.
Yeah, I got the same numbers.
Got the same?
Mm-hmm.
Where's the demo, 1.4787, that's for L. This was 5 or 6, maybe 2 by 3.
For the voltage of the capacitor, I got 302.9301.
For the bottom one, I got -293.57676699.
Something's not right.
And then for the voltage of the inductor, I got -505.1923.
Oh, okay, wait a second. So if you add those together, you do get something.
Somewhat close to that.
No.
Hmm.
Oh, well, no, is it
Wait,
supposed to be
no,
near the
no.
bottom one?
For the VL, I got -436. But,
That's, I think that's farther off. All right.
yeah, that's what I'm.
There's a mistake somewhere. Why don't we take a break here, and we'll see if I can figure out where the mistake is, and then we'll solve it a different way. Right, and recapping what I just said. This was calculated incorrectly here, which affected that, which affected this, and so now the sum of these two is much closer to the current coming out of the power supply. And down here, there were just some miscalculations, and the sum of these two does come out pretty darn close to, it's the fourth significant figure. Is where it deviates. Which is why I wanted you to keep taking extra decimal places, because it shows up here. All right, questions on this masterpiece here? I do recognize this is not the master set problem. Master set problem has, is it capacitor and the inductor, but,
Yeah, the inductor is replaced with the capacitor, like this switch.
yeah, and the inductor is 200 millihenries.
It's just master set, what, 34?
33.
33?
It's off of question 2.
Pardon?
It's similar to question 2, or which one is it?
Question 1 is, what's the formula for the voltage across the power supply? So question 1 basically is this right here.
Mm-hmm.
Oh, I break it down. So what is epsilon sub naught? What's the angular frequency? What's the formula? And then 2 was the phasor diagram, and then finding the angles. 3 was what are the equations? And then 4, it's assume the voltage from the power supply starts at maximum positive value. What's the first time resistor? Voltage phasor is 5 or 6, so that's just a math problem. And then 5 is for that time that you find a problem 4, basically solve for this.
Oh, okay. This is one whole master set we broke into components. Oh, okay.
Oh, I thought it was one problem off the
Yeah,
map.
how the
That-
same
that is-
thing.
That's, basically, this is all the work that would be done doing the physics approach.
You had me scared for a second. I was like,
Yeah.
this is one
I thought we had
question?
5 of these. I was like, dude, I'm done.
I was about to, like,
It was originally one question, and then I broke it up into a whole bunch of parts for the master set.
Epic.
Okay, I feel better now, because I was like,
Alright. I'm gonna do this exact same problem, we know what the answers are, so we can feel good when we get the correct answers, but this is a completely different approach. Well, they are similar mathematically, but,
Without the phasers.
without the phasers. So let's get rid of this stuff. Well,
Dr. Fox.
Yes.
On our final test, we'll be doing phasor diagram, probably.
It's reasonable for me to give you a problem and say, what's to draw the phasor diagram for
Okay.
this. Make sure you include all 8 phasors.
So I was wondering, like, if I like this method of finding the equations better or whatever, do I really need it? I guess,
Do you have to do the phasor diagram?
yeah, is
Alright.
there one I could choose, or?
For the master set, you still have to do the phasor diagram, even if you do the second method. But the difference is that if you're doing the second method, you are gonna come up with the equations before the phasor diagram, and then you'll sort of,
you can work
now
backwards.
that you have the equation, you work backwards, to come up with the answers for. Number 2's got a bunch of parts that, once you have the equations, you can easily solve all from number 2 from the equations.
when is our test?
Last day, March 6th.
Are we retaking the conceptual test?
Yeah, that is scheduled for, because we have next week still, I think sometime next week.
So Monday and Wednesday will be tests.
No, Monday or Wednesday would be the multiple choice test, the following Monday would be the last test.
Isn't this
Is this the second to last
this
week?
is the second to last week, right?
There's still like Monday.
Yes, yeah, there's still a Monday,
Oh, there's a oh.
because we had Martin Luther King Jr. Day off.